Yes, a ground rod is required at the pump station. According to the National Electrical Code, a grounding electrode system is required for all electrical equipment that is permanently connected to a power system. This includes pump stations, even if they are totally enclosed. The purpose of the grounding electrode system is to provide a low-resistance path to ground for electrical fault currents. This helps to protect people from electrical shock and prevents damage to equipment. The ground rod should be driven at least 8 feet into the ground and should be connected to the equipment grounding conductor. This conductor should be run from the ground rod to the pump station's electrical panel. It is good practice to have a ground rod installed at any electrical installation, even if it is not required by code. This can help to protect people and equipment from electrical hazards. The National Electrical Code, or NEC, serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. It is important to consult the latest edition of the NEC and local amendments for specific requirements in location. Grounding and bonding are critical concepts within the NEC. Grounding refers to intentionally creating a lower impedance path from electrical equipment to the earth. Bonding involves connecting metallic parts to form an electrically conductive path, ensuring electrical continuity and the capacity to safely conduct any fault current likely to be imposed. The grounding electrode system serves as the foundation for electrical safety. It typically comprises of one or more grounding electrodes connected to the electrical system. Common types of grounding electrodes include ground rods, ground plates, and underground metallic water pipe. The NEC specifies requirements for the size, material, and installation of grounding electrodes to ensure effective grounding. The equipment grounding conductor, often referred to as EGC, provides a low impedance path for fault current to return to the source. It is a critical component of the grounding system as it helps to trip over current protective devices, such as circuit breakers and fuses, in the event of a fault. The EGC can be a wire, conduit, or other approved metallic raceway. Bonding is equally important for electrical safety. It involves connecting metallic parts of the electrical system to form an electrically conductive path. Bonding ensures that all metallic parts are at the same electrical potential, minimizing the risk of electrical shock. Bonding is typically achieved using bonding jumpers or bonding conductors. The NEC specifies requirements for bonding different parts of the electrical system, including service equipment, enclosures, and metallic piping systems. Ground fault circuit interrupters, known as GFCIs, are devices designed to protect people from electrical shock. They work by monitoring the current flowing in a circuit and detecting any imbalance that may indicate a ground fault. When a ground fault is detected, the GFCI quickly trips the circuit, interrupting the flow of electricity and preventing electrical shock. GFCIs are required in many locations, including bathrooms, kitchens, and outdoor areas. Surge protective devices, or SPDs, are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power line transients. SPD work by diverting excess voltage to ground, preventing it from damaging sensitive electronic equipment. SPD are commonly installed at the service entrance of a building and at individual pieces of equipment. Proper grounding and bonding are essential for electrical safety. They help to protect people from electrical shock, prevent damage to equipment, and reduce the risk of fire. The NEC provides detailed requirements for grounding and bonding, and it is important to follow these requirements to ensure a safe electrical system. When installing a ground rod, several factors should be considered to ensure its effectiveness. Firstly, the location of the ground rod is crucial. It should be installed in an area with moist soil to ensure good electrical contact with the earth. Avoid areas that are excessively dry or rocky, as these may not provide adequate grounding. Secondly, the depth of the ground rod is important. The NEC requires that ground rods be driven at least 8 feet into the ground. This ensures that the ground rod is in contact with a sufficient amount of soil to provide a low impedance path to ground. Thirdly, the type of ground rod should be selected based on the soil conditions. Copper-clad steel ground rods are commonly used in most soil types. However, In corrosive soils, stainless steel ground rods may be necessary to prevent corrosion. The connection between the ground rod and the grounding conductor must be secure and corrosion resistant. Use approved connectors and follow the manufacturer's instructions for installation. Regularly inspect the ground rod and grounding conductor for any signs of damage or corrosion. Replace any damaged components immediately to ensure the continued effectiveness of the grounding system. The size of the grounding conductor is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the grounding conductor based on the size of the service entrance conductors. It is important to use the correct size grounding conductor to ensure that it can safely carry fault current back to the source. The grounding conductor should be run in a direct and unobstructed path from the ground rod to the service equipment. Avoid sharp bends or kinks in the grounding conductor, as these can increase impedance and reduce its effectiveness. The grounding conductor should be securely fastened to the ground rod and the service equipment using approved connectors. Proper grounding and bonding are essential for the safe operation of electrical equipment. They help to protect people from electrical shock, prevent damage to equipment, and reduce the risk of fire. By following the NEC requirements and best practices for grounding and bonding can ensure a safe and reliable electrical system. In this specific case of a duplex suction lift wastewater pump station located approximately 950 feet away from an elementary school, several additional factors should be considered. Firstly, the distance between the pump station and the school may require the installation of additional grounding electrodes to ensure adequate grounding. The NEC specifies requirements for the spacing of grounding electrodes, and these requirements should be followed to ensure that the grounding system is effective. Secondly, the presence of underground utilities, such as water pipes and gas lines, should be considered when installing the ground rod. Avoid installing the ground rod near underground utilities to prevent damage to the utilities and ensure the safety of workers. Thirdly, the soil conditions at the pump station site should be evaluated to determine the appropriate type of ground rod to use. Soil testing may be necessary to determine the soil resistivity and corrosivity. Fourthly, because the power is being supplied from a remote location, the need of a second ground rod at the school should be taken into account. The school should be grounded as well. Additional protective measures, such as surge protective devices, may be necessary to protect the pump station equipment from voltage surges. Consider the electrical characteristics of the pump station equipment when selecting surge protective devices. It is always a good practice to consult with a qualified electrical engineer or electrician to ensure that the grounding system is properly designed and installed. A qualified professional can assess the specific site conditions and electrical requirements to develop a grounding system that meets all applicable codes and standards. Regular maintenance and inspection of the grounding system are essential to ensure its continued effectiveness. Inspect the ground rod, grounding conductor, and connections for any signs of damage or corrosion. Test the ground resistance to ensure that it is within acceptable limits. Replace any damaged components immediately to maintain the integrity of the grounding system. Proper grounding and bonding are critical for the safety of electrical systems. By following the NEC requirements and best practices can ensure a safe and reliable electrical system that protects people and property from electrical hazards. This includes properly grounding the pump station and consulting with a qualified professional to ensure that the grounding system is properly designed and installed. A qualified professional can assess the specific site conditions and electrical requirements to develop a grounding system that meets all applicable codes and standards. Regular inspection should also be a part of the safety. The National Electrical Code also covers the requirements for electrical installations in hazardous locations. A hazardous location is an area where flammable gases, vapors, or dust may be present in sufficient quantities to cause a fire or explosion. Wastewater treatment plants and pump stations may contain hazardous locations due to the presence of methane gas or other flammable substances. The NEC classifies hazardous locations into different classes, divisions, and groups, based on the type and concentration of the hazardous material present. Each classification has specific requirements for the type of electrical equipment that can be used in that location. Electrical equipment that is installed in a hazardous location must be specifically designed and approved for use in that location. This equipment is typically explosion-proof or intrinsically safe, meaning that it is designed to prevent ignition of the hazardous material. The NEC also specifies requirements for wiring methods, grounding, and bonding in hazardous locations. All wiring and equipment must be installed in accordance with the NEC requirements to prevent the risk of fire or explosion. In addition to the NEC requirements, local codes and regulations may also apply to electrical installations in hazardous locations. It is important to consult with the local authorities to determine the specific requirements for location. Proper training is essential for anyone who works with electrical equipment in hazardous locations. Workers should be trained on the hazards of the location, the proper use of electrical equipment, and the emergency procedures to follow in the event of a fire or explosion. Regular inspections and maintenance of electrical equipment in hazardous locations are essential to ensure its continued safe operation. Inspect equipment for any signs of damage or deterioration and replace any damaged components immediately. Proper electrical safety practices are essential in all electrical installations, but they are especially important in hazardous locations. By following the NEC requirements and best practices, and implementing a comprehensive safety program, you can minimize the risk of fire or explosion and protect people and property from electrical hazards. This includes properly classifying the hazardous location, selecting appropriate electrical equipment, and providing adequate training to workers. The National Electrical Code provides detailed requirements for electrical installations in various types of occupancies, including schools. These requirements are designed to ensure the safety of students, teachers, and other occupants of the building. The NEC addresses various aspects of electrical safety in schools, including wiring methods, grounding, overcurrent protection, and emergency systems. Wiring methods in schools must comply with the NEC requirements for the type of occupancy. Wiring must be installed in conduit or other approved raceways to protect it from damage. The NEC also specifies requirements for the type of wire that can be used in schools. Grounding is essential for electrical safety in schools. The NEC requires that all electrical equipment be properly grounded to prevent electrical shock hazards. Grounding systems must be installed in accordance with the NEC requirements. Overcurrent protection is also critical for electrical safety in schools. Circuit breakers and fuses must be sized properly to protect electrical circuits from overloads and short circuits. The NEC specifies requirements for the type and size of overcurrent protection devices that can be used in schools. Emergency systems are required in schools to provide power for essential equipment during a power outage. These systems may include emergency lighting, fire alarm systems, and communication systems. The NEC specifies requirements for the design and installation of emergency systems in schools. In addition to the NEC requirements, local codes and regulations may also apply to electrical installations in schools. It is important to consult with the local authorities to determine the specific requirements for location. Regular inspections and maintenance of electrical systems in schools are essential to ensure their continued safe operation. Inspect electrical equipment for any signs of damage or deterioration and replace any damaged components immediately. Proper electrical safety practices are essential in all electrical installations, but they are especially important in schools. By following the NEC requirements and best practices, and implementing a comprehensive safety program, you can minimize the risk of electrical hazards and protect students, teachers, and other occupants of the building. This includes properly installing wiring, grounding systems, overcurrent protection devices, and emergency systems. The location of a wastewater pump station near an elementary school requires special attention to safety considerations. In addition to the electrical safety requirements of the NEC, there may be other safety regulations that apply to the pump station. These regulations may address issues such as odor control, noise levels, and access control. It is important to consult with the local authorities to determine the specific safety regulations that apply to the pump station. The pump station should be designed and operated in a manner that minimizes the impact on the surrounding community. This may include measures such as installing odor control systems, using sound dampening materials, and restricting access to the pump station. Regular monitoring and maintenance of the pump station are essential to ensure its continued safe and reliable operation. Inspect the pump station equipment for any signs of damage or deterioration and replace any damaged components immediately. Proper safety practices are essential for all workers who operate and maintain the pump station. Workers should be trained on the hazards of the location, the proper use of equipment, and the emergency procedures to follow in the event of an accident. By following all applicable safety regulations and implementing a comprehensive safety program, you can minimize the risk of accidents and protect the health and safety of the community. This includes properly designing and operating the pump station, providing adequate training to workers, and conducting regular monitoring and maintenance.